Hi everyone, so welcome back. We are still discussing about plane areas. This time we will be solving the area using the Wallis formula. Okay, so we have here problem number 1. Find the area enclosed by the curve y squared is equivalent to quantity 1 minus x squared raised to 9. So we were already given our curve. Yes, the curve, it was already plotted. And it is symmetrical with respect to the x and the horizontal axis. So we can use a vertical strip or we can use the horizontal strip. Just make sure that if we are going to use either of the two, we will be having our limits with respect to the x and the y axis. Because if I will be maximizing the full length of the vertical strip, it will cancel out the y high divided by the y low because they have the same equation. So what we're going to do is we're going to consider 1/4 only of the total area, and we simply multiply it by 4 to get the total area. Okay, so area therefore is equivalent to 4 times the integral of, we have y high minus y low dx from 0 to 1. So from 0 to 1, so substituting our y high, we have the integral of, we have y high, so we need to convert that. So magiging, because it is y squared, so it would be the square root of this term. So we have 1 minus x squared quantity 9 raised to 9 over 2 dx from 0 to 1. Okay, so this is a case of Wallis formula because we have a limit of 0 to 1. Okay, so let x is equivalent to sine theta. The derivative of x is equivalent to cosine theta d theta. Okay, if x is equivalent to 1, sine theta is equivalent to 1. Therefore, theta is equivalent to pi over 2. Now, if x is equivalent to 0, so for that is for the lower limit, we have sine theta is equivalent to 0. Therefore, theta is equivalent to 0. So substituting, we have here from this equation, substitute the value of x. So that is equivalent to 4 times the integral of 1 minus sine theta squared quantity raised to 9 over 2. From our trigonometric function, we know that 1 minus sine theta squared is equivalent to cosine theta squared. Okay, but let's so we still have here d theta. Okay, so we forgot the cosine theta because we already substituted dx. So let's place here cosine theta, and the theta should be here. Okay, so that is from 0 to pi over 2. So 4 times the integral of, we have cosine theta squared raised to 9 over 2 cosine theta d theta from 0 to pi over 2. So squared will cancel out with the denominator of the exponent, which is also 2. So that will be the integral of cosine theta raised to the 9th power times cosine theta d theta from 0 to pi. So simplifying further, we have 4 times the integral of cosine theta raised to 10 d theta from 0 to pi over 2. Okay, so from here, we can now use our Wallis formula. Okay, so for our Wallis formula, we know that m is equivalent, no, this is n. N is equivalent to 4. So using the Wallis formula, take note our exponent is 10. Okay, so 10 yung exponent natin. So substituting, we have 10 minus 1, that is 9, reduced by 2, that is 7, reduced by 2, that is 5, reduced by 2, that is 3, reduced by 2, that is 1. Okay, that is 1. Next, we have for the denominator, 10, reduced by 2 is 8, reduced by 2 is 6, reduced by 2 is 4, reduced by 2 is 2, times. So given that our, why is it 4? No. N is equivalent to 10. Given that our exponent is even, we will be having a multiplier of pi over 2. Okay, so the final answer is 63 pi over 128 unit squared. And that is the area of this curve. No, that's not yet. We forgot to include the 4. We have 4 because we have 4 sides, 1 2 3 4. So this is not yet the final answer. So multiply this by, it's already done. No, this is already 4. This is already 4. We just forgot to place here, times 4. Okay, so the final answer is 63 pi over 28, because here in my calculator I already included the 4. Okay, so we have here number 2, find the area enclosed by the curve y squared is equivalent to x raised to the 4th power times quantity 1 minus x squared. So we are already given the curve, so we have 4 parts. So we have 1 2 3 4. So again, I am going to use vertical strip, because if I'm going to use horizontal strip, this equation with this equation is just the same, magka-cancel out siya. Okay, so what I'm going to do is to have 2 equations. So if I'm going to use the vertical and I'll be having my limit with respect to the x-axis, I can have 2 equations. What I'm going to do is simply multiply it by 4 to get the total area. So area therefore is equivalent to 4 times the integral of the square root of x raised to the 4th power minus times 1 minus x squared. Okay, that is dx from 0 to 1. So pwede pa tong i-simplify by raised to 1 half to. This is raised to 1 half. So we can still simplify that. 4 times the integral of, we can have x raised to the 2nd power times the square root of 1 minus x squared dx from 0 to 1. No, this is not 4. This is 2. Okay. Yeah. So that is 2. So the next thing I'll be doing is to assign. So let x is equivalent to sine theta. Okay. The derivative of x is equivalent to cosine theta d theta. Okay. If x is equivalent to 1, sine theta is equivalent to 1, therefore theta is equivalent to pi over 2. Okay. If x is equivalent to 0, sine theta is equivalent to 0, theta therefore is equivalent to 0. So let's try to substitute now this value to our original equation. Area is equivalent to the integral 4 times the integral of, we have x squared, so that is sine theta squared, times we have 1 minus sine theta squared raised to 1/2 cosine d theta, because dx is cosine d theta. And we know that 1 minus sine theta squared is equivalent to cosine squared from trigonometric identities. So that, before that we have here the limit from 0 to pi over 2. So that is equivalent to 4 times the integral of, we have sine theta squared times cosine theta squared raised to 1/2 cosine theta d theta. So squared here will cancel there. So simplifying further, we have 4 times the integral of sine theta squared cosine theta squared d theta. Limits are from 0 to pi over 2, 0 to pi over 2. And there we have it. We can now use our Wallis formula. Okay, so using the Wallis formula, both of our exponents are even. So n is equivalent to 2, while m is equivalent to 2. So we have here 2 minus 1 times 2 minus 1 divided by, we have 4 minus 2, and that is 2. So that's it. Okay, and since it is even, we will be having a multiplier of pi over 2, and the final answer is equivalent to before that we forgot something. We forgot to multiply it by 4, and the answer is equivalent to, we have 2 times 2 times pi times 4 divided by 4 times 2, and that is equivalent to 2 pi. Mali, this is 2 minus 1 pala. Okay, tama na ba? 2 minus 1, 2 minus 1, pi 4, 4 over 2, 4 times 2. Okay, so the final answer is equivalent to pi over 2, and that is unit squared, and that is the final answer, okay, for this curve. Next, we have our third and the last example for this topic. Find the area of the loop of the curve y squared is equivalent to x raised to the 4th power times quantity 1 minus x cubed. So we are already given by with the curve, and the function of the curve is y squared is equivalent to x raised to the 4th times 1 minus x raised to the 3rd power. Okay, so again, what I'm going to do is I'll be using a vertical strip, and that would be from the curve to the x-axis, because if I'm going to maximize my vertical curve, my function will simply cancel out upon derivation of my area. Okay, so area therefore is equivalent to 2, so it will be twice times the integral of, what is the value of y? The value of y is equivalent to, simplifying this, get the square root of this term, that would be x squared times 1 minus x raised to 3 over 2 from 0 to 1. Okay, so I will assign the value of to be the square root of x. No, the square root of x to be sine theta. Why did I assign that? Because if I will let x to be sine theta, the derivative of x is equivalent to cosine theta d theta. Now if I am to substitute this x sine theta to this equation here, 1 minus sine theta, we do not have a trigonometric function for that. So mas mahirapan tayo in terms of exponent. Okay? So we cannot transform that. But if we are going to use the square root of x is equivalent to sine theta, then pwede tayo makahanap ng trigonometric function later on for this one. Okay? So rewriting that, it is x raised to 1/2 is equivalent to sine theta. Okay? So the derivative of x, and that is x raised to 1/2 negative over 2 is equivalent to cosine theta d theta. So cross multiplying, we will be left with dx is equivalent to 2 cosine theta d theta. Then pag cross multiply din natin, we will be having x raised to negative 1/2. And since that is negative, let's make it positive. So this will be equivalent to 2 times x raised to 1/2 cosine theta d theta. And x raised to 1/2 is equivalent to sine theta. So our final answer for dx is equivalent to 2 sine theta cosine theta d theta. And this is the value of x dx. So substituting this to this equation, so area is equivalent to, and by the way, if x is equivalent to 1, sine theta is equivalent to 1, theta is equivalent to pi over 2. But if x is equivalent to 0, theta is equivalent to 0. So the area is equivalent to 2 because we have 1, 2. So 2 times the integral of, okay, so x squared, so that is sine theta, but x, that is x raised to 1 over 2. So that will become sine theta raised to the 4th power times, we have 1 minus x, we have 1 minus, and the value of x is, since that is x, so this will be sine theta squared raised to 3 over 2 dx, that is times 2 sine theta cosine theta d theta. Okay, so for this, simplifying that would be, we forgot the limit, so that is 0 to pi over 2. So 2 times the integral of, we have sine, so that is sine theta raised to the 5th power, bring out 2, that this will become 4. Then we have here 1 minus sine theta squared is equivalent to cosine theta squared raised to 3 over 2. The exponent will simply cancel out, times cosine theta d theta. Okay, from 0 to pi over 2. So this is simply equivalent to 4 times the integral of sine theta raised to the 5th power cosine cube times cosine, so that is cosine theta raised to the 4th power d theta. Okay, so we can now use our Wallis formula. M is equivalent to 5 while n is equivalent to 4. Area therefore is equivalent to 4 times. We have here the exponents. M, we have 5 minus 1, that is 4, reduced by 2, that is 2. And for the n, we have 4 minus 1, that is 3, reduced by 2, that is 1. So for the denominator, we combine the exponent, so that is 9. 9 reduced by 2 is 7. 7 reduced by 2 is 5. 5 reduced by 2 is 3, and 3 reduced by 2 is 1. And since 1 is odd, therefore our multiplier is equivalent to 1. And the area is equivalent to 32 over 315 unit squared. And that is the final answer for this given curve.